turning bauxite into aluminium is incredibly energy intensive. It's in terms of density of load versus the area used, the only thing that is greater than it is data centers.
Oh, right, okay.
Yeah,
right.
Or maybe Bitcoin mining, but they probably count as a data center as well. But basically, incredibly dense load, which is why you see this. And this really spelled out to me just how big a player some of these large companies are now. Hello, and welcome to Environment Variables, brought to you by the Green Software Foundation. In each episode, we discuss the latest news and events surrounding green software. On our show, you can expect candid conversations with top experts in their field who have a passion for how to reduce the greenhouse gas emissions of software. I'm your host, Chris Adams. Welcome to The Week in Green Software, or TWiGS, where we bring you the latest news and updates from the world of sustainable software development. I'm your host, Chris Adams, and I'm joined here with Asim today. Hey, Asim.
Hi.
Oh, Asim, before we go further, we should probably introduce ourselves, shouldn't we?
Yeah, sounds good idea.
Okay, so my name's Chris. I am the Policy Working Group Co-Chair in the Green Software Foundation, and I'm also the Executive Director of the Green Web Foundation. I'm also an organizer at climateaction.tech, and I think that's enough things for me to explain what I do. Asim, I'll hand over to you next.
Yeah, my name's Asim Hussain. I'm the Executive Director and Chairperson of the Green Software Foundation. I'm also a Director of Green Software at Intel and ex-organizer at climateaction.tech, which is where me and Chris, we didn't meet then, but we first started working closely together.
That's when we
then.
started working together.
Yeah.
We met at OMG Climate, an unconference based in London and Berlin, which was a successor to OMGDPR, which is a conference all about GDPR, which was considered quite an earth-shattering thing to be thinking about back in 2018.
Right, definitely shattered the earth a little bit, didn't it, GDPR?
Yeah, a little bit.
Yeah.
It definitely had an impact.
Yeah.
So today, if you're not familiar with the format for this show, we generally run through some of the stories that have come up and share some of the commentary, and sometimes we invite guests on to talk about some of these. I think we've got a few stories here from stuff from Netflix, the environmental impact of refurbished tech from back market, and some interesting news from the policy point of view with both the European Commission and stuff going down in the UK as well. Shall we start, Asim?
Yeah, let's start with Netflix, should we?
Yes, what the latest research on streaming emissions tells us. So this is a piece published by Netflix and in collaboration with the folks at DIMPACT, which I think stands for Digital Impact. So this has a number of real kind of heavyweights in the field. Dr. Daniel Schein, Dr. Jonathan Koomey, Jens Malmerdin, and a number of other companies are sharing data along this, like BT, Orange, Talk, Spotify, and Netflix themselves. They did a bunch of literature review about what the state of the art is for this, and they used some of this to work out some of their own figures themselves. Asim, I think you've had a look at this as well. What caught your eye when you saw this?
Well, what caught my eye was I've been hearing about DIMPACT. Is it DIMPACT or DIMPACT?
I'm not quite sure.
DIMPACT for a while. And Dr. Daniel Schein is a member of the foundation. He's been an active member of the Standards Working Group, amongst other things, for a while. So we've been talking for a while. And just really, I think the paper, as well as the literary review, does it in such a where it actually creates recommendations or what they call them, principles, which is a good way to go. It gives a very direct feedback, advice to everybody else for what to look at. So they've got 4 principles. Should we dig into them?
Yeah, you can run through. These are the ones for the government. So as I understand, this is basically the company saying, okay, government, this is what you need to do so we can do our reporting properly. That's largely it. I think with the idea being that one organization is saying it's too big for any one of us to solve by ourselves. So you're going to have government involved for this part here. That's the argument they're making, at least, as I read for it.
Oh, yeah.
And should we run through these? Because there's 4 and they're relatively catchy. Do you want to start with number 1?
Yeah. Principle 1, expand access to shared contemporary data that is no more than 1 to 2 years old and which does not compromise competitive and proprietary information. Which is interesting because that's actually oftentimes the feedback I hear from organizations regarding being more transparent around data. It's that worry that you're going to be revealing competitive and proprietary information. And I don't know, I will say, now I'm going to be opinionated, I would say it's not even with the greatest understanding that you will. It's the worry that you might. Because if you're an exec inside an organization, it's far easier. You're not going to have a huge mistake by saying no to revealing some data. But the worry is that you're going to say yes to something and then something will get revealed.
You publish your cost structure.
Your cost. Accidentally, you don't realize if you divide it by 5, it's your cost structure. Like you just don't realize that.
Fun factoid. 10 years ago, I worked at a company called AMI, Avoid Mass Extinction Engine. One of the ideas behind some of the carbon accounting was to work with organizations, because if you are upstream and you have organizations sharing their carbon emissions to you, it does indeed give you some idea of what the cost structure is likely to be. And that gives you an idea of who you should be speaking to first in terms of trying to achieve some carbon reduction. So on one level, there is this idea about a cost structure thing, but there's also this idea that if you have deeper supply chain engagement, then there's greater chance to have some mutually beneficial collaboration there. And there was one example of a very large soft drink manufacturer, them working with their suppliers, and they would basically say, look, a huge chunk of our supply chain emissions is from you guys having old fridges. So why don't we actually just agree with you to so you buy better fridges, because it's going to make us look better and you look better. So can you please change your fridges? That's literally how it worked. And this is why I think it's quite interesting, because it works both ways. And there is a kind of mindset shift that may be necessary for this. Anyway, we've got 3 more principles to look at here, because this is quite exciting.
When you do the next one.
Yeah, okay. Ensure appropriate modeling for decision making. This is through continued research to avoid oversimplified and biased results. I think this is actually a reference to the fact that in many cases, there will be models which you say, let's you're looking at something like streaming, for example.
Yeah.
This one here, if you look at the research, Netflix basically say, okay, for what we do, we're looking at about 1% of the emissions come from the data center, 10% from the network, and nearly 90% come from the device manufacturers, like at the end, which is like your tablet or your big screen or your router or like the Wi-Fi on your house, for example, or maybe a TV or digital video box, whatever set-top box you might actually have. And that's a different modeling from what you might see in other services. So if you have something which is entirely web-based, where they're not doing so much streaming of video, then you might have a different setup, because each request has a lot more work going on. You're not sharing the same thing, because the whole point about things like Netflix in many cases is that everyone gets to see the same video, right?
Yeah. So there's a lot of caching.
It would work if every single video was different, right? That would make for a pretty ropey shared experience.
But I think that's also speaking to the fact that I think there has been some pretty simplified, they call it oversimplified. I would also say there is a need for simplified models here as well. But there are like simplified models, I don't want to name any names here, but there are simplified models that people have used for networking in the past, which have come under some criticism. And I can imagine if you're Netflix, those models would overestimate your emissions. I know you just mentioned about the end user device, but they would overestimate your networking emissions
it's
dramatically.
It's going to make you look awful.
Yeah. Whereas the reality is that I think that's what we're talking about. Basically, use good models.
Yeah.
Right, there you go.
So the thing that's worth...
Revolutionary statement there.
The useful statement to reach for this is that all models are wrong, but some models are useful. So depending on what your resolution might be, it might be useful to use a quite high-level model, say sustainable web design for web design. But if you try to use something like the sustainable web design model for Netflix, might not give you particularly useful answers. So that's the second principle. Okay, number 3, go on.
Yeah.
This one is you, I think, Asim.
Principle 3, I love principles. Principle 3, institute energy efficiency requirements for devices and infrastructure, TVs, data centers, internet networks, home devices, etc. Energy efficiency requirements. So it's like an Energy Star aspect.
Yeah, it does sound a bit like that.
Yeah.
And I think this is interesting for 2 reasons. So first of all, various bodies like the GSMA, I think, or GESI, which is GESI, and I think the Science Based Targets Institute, they issued a press release in maybe 2020 basically saying, if we want to hit 2 degrees of warming, we need to basically halve the energy consumption of the entire sector by 2030. And that's about a 7% reduction year on year. So that's what you have there. And we don't have any kind of regulation for this kind of stuff. And in many cases, there's a cadence for which when new bits of technology come in to allow you to scale some of this stuff back, for example. So like routers, for example, when we look at this helpful diagram from Netflix, you can see a significant chunk is actually stuff which is on the subscriber's premises. So that's like your router in your house. And because they are always on, and there's no real kind of sleep process, there is basically no relation there. And when that's taking up maybe say a quarter of the impact they see here. That's a space where it really would be helpful to have some kind of agreements on this. The good news is there is actually some of this described in the next draft of Wi-Fi. I'll have to share a link with this to allow things to scale down.
Oh, really? That work is now actually becoming part of the standards?
It's a really early draft.
Right. Okay.
So I've seen some discussions where people are saying, maybe we should have a way to scale some of this back when we're not sending data over the wire. You see the same thing with the deep connections as well. For some of the really fast connections, what you essentially have is when you have nothing being sent over the wire, to make sure that the system is very responsive when data does come down the wire, you basically have messages saying, I've got nothing to send, I've got nothing to send, I've got nothing to send. So you're still sending stuff, even when you're not sending stuff. So again, it's because people haven't prioritized energy usage for this. So there's a bunch of scope here. So that's a fun one to talk about.
To drive that work, there needs to be kind of requirements for devices to be energy efficient. There's also a software. I just want to be clear. I don't think this is purely a hardware story. This is a software story. A lot of that stuff you just described, it could be implemented in hardware, but it could also there'd be software components to that standard as well. And there's a lot of stuff about switching devices off. This stuff is a software-driven aspect of it. And there's also your TV is oftentimes taking in a stream of data and undecoding it and putting it onto the display. That's a software. We're in that world where you actually the boundary between software and hardware is blurred because you can actually implement a lot of stuff as a hardware aspect of it. But I think there's stuff there as well. You can implement energy efficiency stuff in software as well. And just another random, my TV's hot. Every now and again, I go close to it with my hand and I'm like, wow, this is actually radiating a fair amount of heat. So I think that's something to think through. But anyway.
Yeah.
You don't really think of your TV as a radiator, but mine acts like a radiator for my house.
So you heard it here first. If you want to reduce the environmental impact from your Netflix habits, use a smaller screen or turn on the big hot television that's attached to Asim's wall.
Watch more Netflix shows in winter and reduce your energy bills.
Yeah,
Get out in summer. Get out in summer and enjoy the sunshine and stop watching Netflix in summer is basically that's advice from Netflix, apparently, according to the Netflix report.
Should we move to Principle 4, Asim, before we get in trouble?
Before I get into more trouble. Okay, go on.
Prioritize broad availability of low carbon and renewable energy for companies that operate large-scale infrastructure and consumers, since most streaming emissions come from inside the home. Basically, what they're saying is you need an entirely fossil-free internet, which is what my organization cares about more than anything else.
I've heard that tagline before.
Yes.
Yeah. A fossil-free internet, broad of low carbon and renewable, and that's so important. I mean, when we talk about the pathways to achieving the only viable pathway to achieving the goals of 2030, very fast decarbonization of the electricity grid is pretty much the only path these days, isn't it? I don't know if anybody talks seriously about another one.
There is a bunch of really useful work that's been published by Transition Zero and Ember Climate about this. We can share links to this, but let's not dive in too deeply because we end up being an energy podcast rather than a green software podcast.
There we go. But so that makes sense.
Next one, the environmental impact of refurbished tech. This is a story from Back Market. And I think this is quite interesting. I've shared this, Asim, because Back Market, yes, they're in the business of selling refurb technology. So if you want to buy an iPhone or an iPad or something, rather than buying it directly from apple.com, you can buy a refurb one from them instead.
Which is, I'd actually never heard of them before. So it's really,
Yeah, they're available in quite a few countries, but they're not the only people. They work a little bit like a kind of two-sided market. So they speak to smaller shops that do some of the refurbishing and they connect buyers to this. That. So they're right in the middle. And I've ended up getting into a habit of basically purchasing most of my electronics through them now, simply because there's a really interesting set of stats and research on this, which basically shows that the carbon savings are really quite substantial. So this isn't just like a puff piece. This is actually work from the French, from ADEME, which I'm not going to try to pronounce in French, but more or less translates as the French Environment and Energy Management Agency. They published a study last year to work out just how much of an impact having refurbished or circular electronics might actually be. And I've shared the table here from this report, from the actual link that's in here. And generally speaking, let's say you're going to buy a second-hand smartphone and hold on to it for 2 years versus holding on to buying a new one and having it for 3 years. There's every single saving here in terms of CO2 or water or e-waste. It's above 80 to 90%. So
just so I understand this number correctly, I'm seeing a table and for one cell it's saying smartphones.
Yep.
And then the other dimension
tablets,
is carbon.
laptops and desktops, yeah.
So from a smartphone carbon perspective, I'm seeing the percentage 91.6%. So what I believe that's telling me is I will save 91.6% of the emissions. Why wouldn't it be 100%? It's a refurbished. So I'm a little bit confused in my mind.
There's still an environmental impact from taking something and refurbishing and doing some work on it.
Right. Okay. Yeah. So if I was to keep that, why did they say 2 years and 3 years? I
think the reason is because that's what they typically look at. When people purchase a new machine, they might not hold on to it for so long. There's actually a link to this really detailed report from ADEM, the French agency, where they go into do this like 200 pages long, where they talk about every single possible scenario of 1 year ownership versus 5 year ownership. Are you buying a second-hand one that's 2 years old versus 5 years old? It's like every permutation you could imagine. But the high-level stats here are basically the key takeaway is that buying something refurbished is a really effective consumer way to reduce the environmental impact of the electronics you have. Or conversely, how guilty you feel about your gadgets habit, basically.
Yeah. And I think it also speaks to I won't say fallacy, I will say the misunderstanding of the effectiveness of recycling. Because recycling, you really will not get anywhere close. I don't know what the statistic is, but it will be nowhere close to 91.6% for a smartphone. Reselling something or just giving it to somebody else rather than throwing it away is one of the best things to do. It's actually, but it's still, that's why I love it. I've really got to check out Black Market. Sorry, I called it Black Market because that's what I first read when I saw it. It's the Black Market, but it's the back
As
market.
In take back or give back.
Right, okay. I'm going to call it Black Market by accident many times from this point forward. But I think that's a really important aspect because I think one of the challenges people have for refurbished stuff is a lack of trust. Mm-hmm. I buy stuff from eBay all the time, but I have it with this. What am I going to get? Whereas getting some form of kind of trust of interest, do they offer a guarantee or something? You buy it from Back Market?
Yes, they do.
That'd be amazing.
Where are we turning this into a advert for them? Because basically, I purchased all this. I think I've pretty much got my phone, an iPad, and my work laptop through this one company. They're not the only company doing this. In the UK, there's an organization called Tech Buyer. There's plenty of other ones, but I've been pretty happy with this, and I've got a year warranty from this. And basically, because computers their speed is not improving at the rate they used to be.
Yeah.
It's okay. So I've got a machine from 2020 that I bought secondhand, and it's banging. It's really good. I'm really happy with that, and that's enough to last me for the next few years.
You just need a web. What is it? 60-70% of all apps is just web. Just browsing on the website. We've solved that. You've got a laptop that's good enough for that, and it'll be good enough for it for a long time.
And it's just as well because there's changes in the law coming down.
Oh, yeah.
In particular, this is the next story that is somewhat related to this. One of the reasons that has been a problem with getting these things like devices lasting longer is that if a single thing broke, you basically didn't have an easy way to get it repaired or replaced or anything like that. And there's been some interesting new laws with a new right to repair law, which will require hardware makers to provide fixes for up to 10 years from new electronics. So that's so much further for this. And basically, the idea, it's still being drafted when it comes to actually being implemented in different countries. So just because it's plastered at the European level, you still need someone to implement the interface, as it were, in Germany or France or stuff like that. But generally speaking, things like hardware, cell phones, tablets, the goal is to have things at least 5 years and up to 10 years of that, and also providing clear access to all the bits that you might need to repair these. Yeah,
this is kind of like, I think iFixit, are they a non-profit or a for-profit? I can't remember, but this is kind of what iFixit has been trying to do, which is figure out how to repair things when manufacturers have provided no information about how to repair it. And they're just like smashing up 50 iPhones just to figure out how to repair an iPhone. And then they're publishing the information online. But this is saying this is actually going to have to be law. Oh, it looks like there's still some negotiation that needs to be done here. But it'll be law for organizations to affect, even beyond the guarantee period. It's saying for 5 to 10 years. 5 to 10 years.
Yeah.
You have to make something is repairable. That's amazing.
I know. It's pretty cool, right?
This is how the world used to be. The world used to be anything. I don't feel old. I do not feel that old. But I do remember repairing things. Repairing things was like electric things was a normal thing to do. You went to repair shops and you got things repaired and you brought them home. And these days, it's almost impossible to repair anything. And the times when you do go and try and repair something, the cost of repair is so much higher not higher, just almost the point where you're like, another 20% more, I can buy something new, and then you get that world. Whereas I love the idea of whole cottage industry of repairing things has almost been lost. And now that generative AI is going to take the rest of our jobs, maybe our jobs will be, maybe the only jobs will be left will be repairing the machines which the AIs need to survive. Maybe we'll be in service of the AIs to repair the machines for them. Okay, there we go.
Topical. I like it.
There we go.
Okay, this is the thing. We'll see how it shapes through before. For folks who are more interested in this, there's a really nice podcast from the Restart Project, because last month there was London Repair Week, where there's a bunch of interviews with people who actually are doing repairs of electronics and talk about how it's changed or what some of the trends might be. We should share a link to that because it's quite fun. It's quite a nice kind of uplifting and happy story, when usually a lot of things around climate and technology can be a little bit hard work. All right.
It's interesting. Do you think that as Moore's law and all this other stuff, it's not slowing down? I don't know. There's other things that are happening. The law's not that simple. But as technology moves, is the fast-paced nature of technology the thing that's made things harder to repair? And now that maybe technology will move slower, you just mentioned your laptop's it gives more room, more breathing space for people to try and repair things.
I don't think it's that. I think it's more a case of business models, right? So even one of the things you did see, because in America recently passed a recent right to repair law themselves, and organizations which have been who have been pushing back against this, one of the tactics they've basically said as well, okay, what we're going to do, we care about the sustainability of things, but you can only ever return things to us. So therefore, we're going to capture the entire value chain ourselves rather than share it with anyone else. And that's very much a deliberate decision that some people have made to say, we're going to be it. And if we get devices from anyone else, we're going to either withhold the parts, which means you can't create a whole kind of secondary market around this. You'll see things like that. And I think this is one of the issues. It's very much a case of how people design things. Because even if you look at, say, a hardware point of view, there are examples like the Framework laptop in America, which is essentially a laptop designed to be the opposite of, say, an Apple MacBook, which honestly I own because I'm stuck using Apple devices. But basically, this is this thing.
You're in the ecosystem, and that's how it's designed.
Exactly. So this is very much a function of in my view, the business model for this. So even if I wanted to have some things which were not the same, the fact that I'm locked in using the same operating system means that I'm not able to do that. And that kind of integration isn't really addressed with this right now. And I feel like in many cases, it's a case of which feudal landlord do you want? Do you want Microsoft? Do you want Google? Do you want Apple? Right?
Okay.
You can do everything yourself, but then you're open and vulnerable against all the bandits and everything like that. But then you have to realize, accept that, maybe the feudal landlord has shareholders to return to, and the priorities are making sure those guys are happy rather than you're necessarily happy. So that's some of the things you have to worry about, really.
Well, I think it's interesting. I think there's parallels here between the kind of the closed source and open source ecosystems as well. It's like there was a huge, like what you just described about you can only return products to us as a closed source system. I think there's definitely cases where the open source model has been more successful than the closed source model. I'd also probably argue this case where the closed source model has been more successful than the open source model as well.
I don't think we're going to resolve this one on this
podcast. Do you really think so?
Not this one. I think there's plenty going either way for a bunch of this.
Okay. All right.
Should we look at the next story that's on here?
Yeah, go on, yeah.
Okay, all right. So Microsoft wants to export Grid Interactive Dublin data center setup. So this is a story that I think is interesting from the perspective of kind of green software developers, because it's work by Microsoft, who have basically been working with a power management specialist called Eaton to build kind of grid interactive UPSs into their data centers. So this basically means that rather than just having backup energy, which just sits there doing nothing, the idea is that the backup battery could supply energy into the grid if necessary. So this basically allows you to kind of smooth out, say, spikes in demand or stuff like that. And you can see it as a kind of complement to renewable energy sources being somewhat variable and at times intermittent. And what they're doing is this is about them saying, we've got this set up we're going to do it in lots of other places. And we're going to start with Ireland because Ireland only gets maybe 35% of their power from renewable sources. But there is a really aggressive growth in data centers planned in Ireland, or that we've seen over the last few years. So this is actually quite an interesting one. And I think that the person that might have been related to some of this work, a chap called Connor Kelly, he published a paper about this idea of balancing power systems with data centers. I think, Asim, this is I used to work at Microsoft. I reckon you might have some reckons on this one.
Yeah, I know Connor. In fact, we should probably reach out to him, see if he wants to come on the podcast. Because Connor, if you're listening, as of course, you always listen to our podcast, you're welcome to come on. Yeah, he's been in this. I wouldn't be surprised. This looks like it's got Connor's fingerprints all over it. Yeah, so I think from my understanding, so just though I'm going to break it down for everybody. So data centers have a lot of backup power supplies. Sometimes they're actually diesel, but they sometimes actually are battery powered. Sometimes actually hydrogen batteries or all sorts of stuff. But this is a battery powered backup. And the point here is, can you reverse the energy back out onto the grid? And therefore be effectively like a short-term battery, act as a battery for the grid, and therefore make money, which I think is a really, maybe probably do want to make money, but I'm sure they have other relationships with the utility providers, like reduced fee or something like that. That's interesting. And I think it's also interesting because I remember I was talking to somebody ages ago in this space about carbon-aware computing, and I was talking about shifting compute. And they raised the point, well, if all of our data centers have batteries, why not just shift the energy? Because if you shift compute, it's like, if you take the opposite side, it's like you're shifting energy. So we've got batteries, shift the energy. And I was like, that's actually quite a great idea, actually. Just shift the energy from France to, whatever.
So this is the work that I think is most interestingly demonstrated by the work on I think EcoVisor is the name of this kind of series of projects, where the idea was that rather than software just knowing that there's power coming in, software has some idea about what quality of power that might be saying, this is the grid power and this is the carbon intensity of this, or here's renewable energy that you might have attached to a data center and this is what the carbon intensity of this is. And this is how much battery power is available and how many hours of battery is available, and also what the kind of carbon intensity of that might be. Because if you were to charge that battery when there's loads of wind on the grid, then you've got really green energy, which in many ways may be greener than the grid power that you have. So if you wanted to say optimize for the greenest possible power, you might choose to only run on, say, battery when the grid intensity was particularly high, if you were able to figure out where you were pulling the power in from. If you're saying, don't feed me grid power, but please feed me power from the battery and from on-site solar or on-site renewables, then you're able to control the actual power going into the system. And there is the thing that's really cool, I did a talk about this because I was so excited about it when I discovered it at FOSDEM. This idea of kind of virtualizing the different kinds of power, I think is one thing that if I wasn't doing what I was doing, I would try to build a service and build a company around it, basically.
Virtualizing, describe what you mean.
So, we have virtualized compute, pay for compute, storage, and network, yeah?
Yep.
It's a big physical machine, but it's exposed to you in the form of a computer which is just the right size, just has enough memory, just has enough of this, right? Now, if you know that, say, your computing jobs don't need to happen right now, they're not time sensitive, then you could say, okay, I only want to be fed on variable power, for example, renewable power. I don't need it to come from the grid because I value that it's greener and it's cheap more than it being available all the time and dispatchable. And I think that people who actually have batteries inside data centers, I think people will figure out how to turn that into a product that you can sell as make available inside this, because I think that's a kind of value added thing that you could quite easily add to cloud compute, to just say, buy the extra green stuff inside it, which for sure has come from the power that's stored at certain times.
Oh, I see.
Yeah, you can segment out the power that way.
Yeah, because I've always wondered about that, about battery, because if you're a wind farm, and I sell electricity, I can then sell a rec, and that's how you signal that my electricity was green.
Mm-hmm.
But if I have a battery on the grid, and currently I know the grid is 50% green, 50% fossil, and I'm storing that energy, I know that electricity is half green, but no one else would know. That's what I mean by virtualized. So if I was to then send that back out onto the grid, I could then give there's a half rec here somewhere, or I don't know how that would work actually.
Well, you just don't decouple the greenness from the power.
Right,
that's a whole kind of silly market construct that only happened because for historical reasons, right? If you actually just treat the power like it really is.
Market.
Yeah. then you could totally do stuff like this. And that is the premise behind this EcoVisor concept, which I think is super exciting and even has an API to implement.
Oh, yeah, okay.
Yeah, exactly. If you virtualize the compute, why don't you virtualize the power? And that allows you to purchase things differently. Because I think there are people who would basically say, okay, I'm using a bunch of cloud services. If there's a way for me to just purchase a kind of greener quality of power from this for certain parts, then I would. Because that allows you some more tools as a designer of services, for example. If you know that, like, then maybe I can pay for, say, 8 hours of definitely green power, for example, then I can redesign the rest of my time to either I can redesign my compute to work within that budget, or I can say, I know I don't have to, see what I mean? Yeah, you could do a bunch with all these new system designs.
Completely not thinking about Rex in the slightest. Yeah. Just thinking about the whole, just like, blank. Interesting.
This is also why the discussions, and if you look on the you look at the trends for grids, there's a huge amount of battery storage looking to be connected to the grid, both in the UK and in America, for example. Masses, and it's growing so fast.
As in it's there, but it's not physically connected to the grid. What do you mean? Or do you mean
it's being connected, or people, because you need to apply for permits for a bunch of this stuff.
Right.
It's basically being permitted and being fed into the grid. So traditionally, you might have relied on, say, things like open cycle gas turbines, which have really this stuff. You, as batteries come into this, that means that the kind of marginal intensity was, you don't have the same signals, basically. So you can't be sure that it's going to be open cycle gas turbines that are powering that marginal power now. So a lot of the assumptions we make about marginal intensity may not be the same, which is why in many cases open some of this up. And if you just look at the location-based amount, then I think it's actually an exciting new horizon opening up to us. And I reckon Connor's probably got something to say about this, because this paper that I read, I thought this sounds super cool, because it basically uses data centers like CDNs, but for power, essentially. In the same way that a CDN relieves pressure on network by, rather than you congesting commonly used channels with lots of the same things being sent over, you're just getting it from somewhere nearby. So you can think of transmission in the same way. If you have a way to reduce the need to fetch power from somewhere else by getting it from somewhere nearby, then you've essentially taken this idea of a CDN, but you've applied it to grid services. And I think that is actually, there are so many places, there's so much overlap in this stuff, there really is. And I think more people should be discussing this, because the cloud as a utility, once you start thinking about these things as utilities, then all these ideas which have been developed for decades in other fields become applicable in our world as well.
I'll just say one thing, and I think we were talking about getting Adrian Cockcroft in, but I listened to his talk at QCon last week, and one really interesting statistic he said, which I thought was fascinating, but if you add up all the power from all the major clouds, it actually becomes one of the top 10 energy utilities in the world.
But it's not just that. There's a crazy figure I saw recently. So if you look at, say, which companies have been purchasing all the kind of corporate green energy power purchase agreements in Europe, right? Amazon is responsible for 19.9% of all the PPAs, the capacity, in the last 10 years, so 20 to 13. Google is 7.4%. And that's like the next two largest organizations are Alcoa, which makes aluminium, and Norsk Hydro, which is basically, it's really eye-opening seeing these numbers. So these are the stats from Wind Europe, and I'll find a link for this. I didn't realize that nearly 30% of all of the PPAs, the power purchase agreements for renewable power, has come from big tech firms.
Which is, just to be clear, you're not saying that's 30% of all energy or 30% of all renewable energy, but 30% of all these things called power, which we won't go into, which is still a significant amount just to go to some tech company. That's how belittling of me, just to go through a couple of tech companies. But aluminium, I've always heard, is like quite significant.
Yeah, turning bauxite into aluminium is incredibly energy intensive. It's in terms of density of load versus the area used, the only thing that is greater than it is data centers.
Oh, right, okay.
Yeah, or maybe Bitcoin mining, but they probably count as a data center as well. But basically, incredibly dense load, which is why you see this. And this really spelled out to me just how big a player some of these large companies are now in the kind of shifting of the grid and how that might impact what we do as developers and people building digital services.
Which is why things like grid, what are we calling it? I've forgotten the term. Grid
interactive is what they said.
Yeah, grid interactive batteries. Yeah, that's why it's so important. Yeah, that's why it could be quite significant.
You say potentially. And one of the reasons you can get the idea that people are doing this just for the goodness of their own heart, right? And the link story basically says they're not just doing it out of the goodness of their own heart. They're doing it because it makes financial sense a lot of the time. So when you are a large organization, you do a big power purchase agreement like this, you're going to get power way cheaper than other people because you're buying in so much bulk. So yeah, you get to say that you're green and everything like that.
I guarantee if you're creating utility scale kind of grid interactive batteries, you're getting a better deal.
Absolutely.
There is definitely a financial. And I want to say, like, one of the things that's quite surprising to me actually was to find out that the interrelation between gas and renewables, which is an unfortunate kind of temporary in the decarbonization of the grid, you do need to be able to create electricity very quickly when the wind dies down. And currently for a lot of places, that's now gas. Whereas that's why kind of battery solutions are so important, because we don't want that to be gas. We want that to be non-fossil solutions. Yeah.
Yeah, basically. If you can find a way to avoid burning fossil fuels to quickly respond to changes on the grid, you need to generate power quickly or reduce power quickly.
Yeah.
And this is what some of this stuff makes possible, essentially. So you can either reduce demand from data centers or feed power in instead of the gas. Yes.
You know how much we try every single episode to not be a podcast about the energy system. We end up being a podcast talking about the energy system.
We're talking about distributed systems. And
there you go.
And like the internet and the grid, there's lots of similarities between these two things. So anyway, we can move away because we're talking about the idea that if you are prepared to be flexible on this, then you can get paid quite a lot of money for this. And that doesn't mean that it's okay for you to be doing this stuff. But if you say that you're only doing this out of the goodness of your own heart, maybe changes in the law that mean that you're not really allowed to say that now. And this is some of the new stories. There's the next story, actually.
EU Commission's Anti Greenwashing Law proposal.
Yeah. So this was published, I think, end of March was the draft version of this, which basically says that later on this year, pretty much there'll be a moratorium on new kind of certification schemes, if anything, marking something as green. And also, you'll only be allowed to use a certain set of really explicit, like the greenhouse gas protocol and stuff like that. They're going to say every single claim has to match up to this stuff here. So there's going to be some really much more stringent stuff. And there'll be like injunctive things saying that if you don't, we can basically force you with the full force of the law to stop you talking about power being green, for example, or things being percentage or things being ocean friendly, for example.
Is that driving things more to certain well-defined terms, like academic terms? If you say the word, when you say you're 100% powered by renewables, I'm like, okay, let's break that down for a second. What do you mean?
Yeah.
You know, like, what does that exactly mean?
So the early version I saw in the stats basically is quite nerdy in terms of it's using all the kind of recent technical language. And there is probably going to be a challenge in terms of how people communicate that, because the good example of this is Ireland, once again, because we're talking about Ireland anyway, right? What we saw before this was that the advertising agency in Ireland basically banned energy companies using the term 100% renewable for power in Ireland, because Ireland only has 35% of its power coming from renewables. Right, so therefore, it can't possibly be 100%, right? And it has implications for all the people running data centers in Ireland, right? So suddenly, where people have been talking about, oh yeah, our cloud's super green, 100% green, now you've had the laws basically saying, no, that's not allowed to, you can't make those changes. And let's go to the next story, has a similar thing to this, because you're seeing a similar story in the UK. The Digital Markets Competition and Consumer Bill is going through law. And this is a bit like the GDPR. The idea is that if you are making misleading green claims and you continue to make them when you're told to stop, you will be liable to fines of up to 10% of global turnover for misleading green claims. So this might explain...
No one's going to say anything about green at all from this point forward.
I think this is the thing that was interesting, because back to the world of cloud, recently Amazon used to have 100% sustainable as one phrase that was used. But in the last year, there was a change to say up to 90x% renewable instead. And I was wondering why they made these changes, because Google say we're 100% renewable. Microsoft says we're 100% renewable. Amazon has been really weirdly coy about this. And I wonder if it's because they saw this lawsuit coming through, realized that even if you are following the letter of the law and the way that, you know, if you purchase enough renewable credits, you get to say your stuff is green. if it's seen as misleading to consumers, then you're still not allowed to. It may be that like organizations, they were being a bit careful about this stuff because, yeah, there's a real shift in this stuff happening, basically.
Well, I welcome this. I think one of the challenges that I see in our space, and it's something that I've talked about, I think, before, is the different languages that organizations use. Like I was picking something up the other day, I think it was some food, and it had written on it carbon negative at the top, which is a term which has no legal definition, carbon negative. And underneath it, in smaller writing, it wrote climate positive. And I was like, okay, so it's carbon negative and climate positive. What do both of those things mean? And it's like so much left to interpretation. Whereas if we landed on, like we work in standards in the foundation, if you land on a very standard definition of this stuff, I think that's really beneficial to the end user. I think, yes, it might take some time for them to learn the language that we're talking about, but they will bother to learn it because finally, when somebody says something, they'll understand what it means. Yeah,
I agree. I think this is positive. I think it possibly suggests a problem for yourself as a director of the Green Software Foundation and myself, a director of the Green Web Foundation. So we have to might end up with a much less catchy sounding name of our respective organizations, Asim.
Oh my word, yeah. Okay, whatever, I'll take it.
Okay, all right. So we're just coming up to the end. Should we wrap up? Are there any events or things that we should be pointing people to? Or is there a list of upcoming conferences we might tell people about?
Probably as we get closer to Earth Week, there's a bunch of meetups being launched through the foundation. People are running a bunch of things around Earth Week. But yeah, we'll talk about it at a future episode.
For next week. All right then. That's it for our news and events roundup for this part. All the resources in this episode and more about the Green Software Foundation are in the show description below if you're looking at this podcast. And you can also visit podcast.greensoftware.foundation in your browser. And if you did enjoy this show, please consider leaving a review on Spotify, Apple Podcasts, or wherever you get your podcasts. Your feedback is very valuable, helps us reach a wider audience, and hopefully helps improve the content of this show. So thanks again for listening, and we'll see you on the next episode. So bye from me.
And bye from me.
All right. Ta-ra.
Ta-ra.
Hey everyone, thanks for listening. Just a reminder to follow Environment Variables on Apple Podcasts, Spotify, Google Podcasts, or wherever you get your podcasts. And please do leave a rating and review if you like what we're doing. It helps other people discover the show. And of course, we'd love to have more listeners. To find out more about the Green Software Foundation, please visit greensoftware.foundation. That's greensoftware.foundation in any browser. Thanks again, and see you in the next episode.